Okay, so in the previous videos we saw the relationship between the zero of a linear polynomial. A linear polynomial is basically something of the type, for example, px is equal to ax plus b. For example, I don't know, let's say p of x is equal to 2x plus 3, for example. If you have this polynomial, the zero of this polynomial is the value of x for which the output of the polynomial is basically 0. Okay, and that happens, and you can find the 0 by basically setting the polynomial equal to 0, and then find the value of x for which the output of the polynomial is equal to 0. That means that if 2x plus 3 is equal to 0, then 2x is equal to negative 3 and x is equal to negative 3 by 2. Okay, so that's basically negative 3 by 2. And negative 3 over here is basically, this over here is your b, and this over here is your a. So your x is basically equal to negative b by a. So the zero of a, so then you can say that, and you can see the same thing over here, meaning that if ax plus b is equal to 0, then ax is equal to negative b, and then x is equal to negative b by a. So that's basically what that means is that the zero of a linear polynomial is negative b by a. Now, if you want to, so that is some sort of relationship between the zero of a linear polynomial and the coefficients of that part of the same polynomial. Now, if you want to do the same thing for a quadratic polynomial, there is still some sort of relationship there as well. And for a quadratic polynomial, basically you have p of x is equal to ax squared plus bx plus c, and then now if you try to, if let's say that you have, for example, for example, some polynomial, some example polynomial, as for example, let's say p of x is equal to 2x squared minus 8x plus 6. Okay, so now if you want to find the zeros of this polynomial, what you can do is that you can factorize it, meaning that you can write the middle term in such a way that then you can basically find you can basically write the middle term, rewrite the middle term in such a way that you can factorize your polynomial. And the way that you do that is that for example, in this case, what I would do is that I would write this as 2 times x squared minus 4x, for example, plus 3. Okay, and so that is 2x squared minus 8x plus 6, and then I would rewrite this middle term as, for example, so you have so basically over here, the way that you do it is that, let's say that you want to factorize this polynomial. The way that you do it is that you have x squared minus 4x plus 3, and you are basically looking for two numbers a and b, such that a times b is equal to 1 times 3, you have a 1 over here and a 3 over here, so 1 times 3 is equal to 3, and a plus b is equal to negative 4 over here. So you have a negative 4 over there, and so basically a times b is equal to 3. That could be, for example, 1 and 3. And a plus b is equal to negative 4, so you can take both of them as negative 1 and negative 3. And so a plus b is equal to negative 4, a times b is equal to positive 3. So your numbers are negative 1 and negative 3. Negative 1 and negative 3. So then you can rewrite this as x squared minus basically negative 1x or negative x, negative 3x plus 3. And then you can take these two terms together and take an x out, so x minus 1. And from these you can take a negative 3 out and write this as x minus 1. So that would be positive 3, negative 3x. And then you can take the x minus 1 out and write this as x minus 3. So that's x minus 1 times x minus 3. So this is equal to 2 times x minus 1 times x minus 3. Okay. So now the zeros of this polynomial are basically, so this is equal to p of x, and this is also equal to p of x. So now the zeros of this polynomial are the values of x for which p of x is equal to 0. So p of x is equal to 0. That means that 2 times x minus 1 times x minus 3 is equal to 0. Of course, you know that 2 cannot be equal to 0, so either x minus 1 is equal to 0 or x minus 3 is equal to 0. And in this case, x is equal to positive 1. In this case, x is equal to positive 3. So these are basically the zeros of this polynomial. That means that if you set in this polynomial over here, if you have p of x is equal to, for example, 2x squared minus 8x plus 6, if you calculate p of positive 1, what you will have is 2 times 1 squared minus 8 times 1 plus 6, and that's equal to 2 minus 8 plus 6, and that's equal to 8 minus 8, which is equal to 0. So you see your output here is equal to 0. And also for 3, if you calculate p of 3, that's going to be equal to basically 2 times 3 squared minus 8 times 3 plus 6. So that's equal to 2 times 9 minus 24 plus 6. And that's 18 minus 24 plus 6. And that's equal to, so that's 24 minus 24, which is equal to 0. Okay. So now, long story short, these are the zeros of your polynomial, and your polynomial was p of x is equal to 2x squared minus 8x plus 6, and your x1 was equal to 1, and your x2 was equal to 3. Okay. Now there is a relationship between these zeros and basically the coefficients of your polynomial, meaning that if you write this as the general form of this polynomial would be ax squared plus bx plus c. Okay, and so here a is equal to 2, b is equal to negative 8, and c is equal to positive 6. Now if you write x1 times x2, that's equal to 1 times 3, which is equal to 3. And that's equal to basically, it's equal to, or let's start with the sum of the two zeros. So let's say that x1 plus x2, that's equal to 1 plus 3, which is equal to 4. And that's equal to so negative b by a. That's equal to negative b by a, meaning that that's equal to negative minus a negative of negative 8 divided by 2, which is equal to 8 divided by 2, which is equal to 4. So 4 is equal to 4. So what that means is that x1 plus x2 is equal to negative b by 8. So that's basically one thing that you can see over here. Also, if you multiply the two roots together, x1 times x2, it's going to be equal to 1 times 3, which is equal to 3. And that's equal to 6 divided by 2. 6 divided by 2, which is equal to c by a. Which is equal to c by a. So you can write x1 times x2 is equal to c by a. And usually in mathematics books, how they write this relationship, they write it as the two roots or the two zeros, they take them as alpha and beta. So this is alpha, for example, this is beta, and they write it as alpha plus beta is equal to negative b by a, and also alpha beta is equal to c by a. This is the kind of thing that you usually use a lot in, at least in the first year of your university or so. So that is basically that. So that is that. So in order, we could have another example as well. For example, let's say that you have another. Let's take the example of another polynomial as well. Okay, so let's see what we can do here. Okay, so as another example, let's take the example of the polynomial. Let's say you have p of x is equal to, for example, 3x squared plus 5x minus 2. Okay, and well, these polynomials are a little bit tricky. I mean, for example, the previous polynomial that we factorized, in the case of that polynomial, we could actually make the coefficient of x squared 1, and then that's easy, meaning that, for example, what we had was basically 2x squared minus 8x plus 6, and then I factored out this 2, so then you have 2 times, for example, x squared, 2 times x squared minus 4x plus 3, and then that way you were looking for two numbers a and b such that a times b was equal to 3, and for example a plus b was equal to negative 4. And we found the numbers, and it was easy to find the two numbers that way. But over here, if I want to take the 3 out, you see that 5 is not divisible by 3, for example, or 2 is not divisible by 3, so I would get a 5/3 x and negative 2/3. But let's see how we can factorize this polynomial here. Let's see how we can factorize this polynomial. Oops, sorry. Let's see how we can factorize this polynomial here. Okay, so basically in such cases, what you want to do first, you could basically, if in order to factorize this polynomial, you could be looking for two numbers a and b, such that a times b is equal to 3 times negative 2, which is equal to negative 6, and a plus b is equal to 5. So the numbers could be, for example, 3 and 2, and one of them has to be negative 6 and 5. So 6 could be, for example, 3 and 2, and it could be also 1 and 6. So if one of these, I think we cannot use this one. So if we go with this one, and then I have to make one of the numbers negative because the product is negative. So I make this negative 1 and positive 6, so 6 minus 1 is equal to 5, and 6 times negative 1 is equal to negative 6. So I write this as 3x squared and minus x plus 6x minus 2, and then I can, for example, take these two together and take a 3x out. So x plus 2, and take a negative 1 out from these two, and that would be x plus 2, right? And then this is going to be equal to 3x minus 1 times x plus 2. So these are the factors of your polynomial. So now p of x, you can write it basically 3x minus 1 times x plus 2. Now in order to basically, in order to find the zeros of your polynomial, you have to set your polynomial, set it equal to 0. So that means that 3x minus 1 times x plus 2 is equal to 0. So if this is equal to 0, either this one is equal to 0 or this one is equal to 0. And if 3x minus 1 is equal to 0, then 3x is equal to 1, or x is equal to 1/3. And if this one is equal to 0, then your x is equal to negative 2. Okay. So now again we can check for this relationship between the roots of your polynomial and the coefficients in your polynomial. So here basically you can see that a is equal to 3, b is equal to 5, and c is equal to negative 2. Okay, and alpha and beta, the two roots of your polynomial, are alpha is equal to 1/3 and beta is equal to negative 2. So if you go for alpha plus beta, this is equal to 1/3 minus 2, which is equal to 3. 1 minus 6, so that's negative 5/3. Negative 5/3. And that's equal to actually negative b by a, which is equal to negative b by a, because b is 5 and a is 3, so negative b by a would be negative 5/3, and that's exactly what I've gotten here. And alpha beta is equal to c by a, and let me actually do it the other way around. So alpha beta that I have found are actually 1/3 times -2 times -2, which is equal to -2/3. And that's actually equal to c by a in your polynomial, which is equal to c by a. And if you calculate c by a, that would be -2 divided by 3, which is equal to -2/3. So again you can see that alpha plus beta is equal to -b by a, and alpha beta is equal to c by a. So you can use these two relationships extensively in many different applications, and that's basically the whole story here. Now we have a couple of examples here that we can go through. We can go through, so let's do a couple of them. So for example, what you want to do is that you want to find the zeros of the quadratic polynomial. Find the zeros of the quadratic polynomial x squared plus 7x plus 10, and verify the relationship between the zeros and the coefficients. Or for example, you want to do that. So first of all, in order to find the relationship, to find the zeros, you can, let's say that this is p of x, for example. Okay, and in order to factorize this polynomial, you are basically looking for two numbers a and b, such that a times b is equal to 1 times 10, which is equal to 10, and a plus b is equal to 7. So that could be basically 1 and 10. That could be a times 10 would be 2 times 5. Okay, so I think we could go with these two numbers. But and a plus b is equal to 7, and a times b is equal to 10. So these are the two numbers that you can try. So you can write this polynomial as x squared plus 2x plus 5x plus 10. Okay, and then you can take for example these two together, and take these two together, and from these two you can take an x out and write it at x plus 2, and from these two you can take a 5 out and write this as x plus 2, and you can write this as x plus 2 times x plus 5. So that's basically your polynomial factorized. Now in order to find the zeros are basically the values for x for which the output of the polynomial is equal to 0. So basically you set, so this is basically all p of x, this is p of x. So if you set p of x is equal to 0 to find the zeros, that would mean that x plus 2 times x plus 5 is equal to 0. And that if this is equal to 0, either this one is equal to 0 or this one. So that means that either x is equal to -2, or basically your x is equal to -5. These are the two These are the zeros of this polynomial. Now, if you want to check the relationship between the zeros and the coefficients of the polynomial, we said that alpha plus beta was equal to negative b by a. Alpha plus beta is supposed to be negative b by a. So what is alpha and beta? So this is, for example, let's say x1, x2. So call this alpha and call this beta. So that is negative 2 plus negative 5 is equal to, so this is alpha plus beta is equal to this thing. So this is equal to negative 7. And negative b by a here is equal to, the polynomial was p of x is equal to x squared plus 7x plus 10. So this is your b, this is your a here is equal to 1, and this is your c. So negative b by a is equal to actually negative 7. So negative 7 by 1, which is equal to negative 7. And as you can see, and therefore you can see that alpha plus beta is equal to negative b by a. Okay, so that's basically the first relationship. The second relationship is alpha times beta. So alpha times beta here is equal to negative 2 times negative 5. Negative 2 times negative 5, which is equal to positive 10. And c by a here, c by a in this polynomial is equal to 10 divided by 1, which is equal to 10. So you see that alpha beta is actually equal to c by a. And that's basically the two relationships that we have regarding the roots and the coefficients basically verified. Let's do another example here. So for example, let's say that you have find the zeros of the polynomial x squared minus 3, and we want to verify the relationship as well. So for example, let's say that you have a polynomial p of x is equal to x squared minus 3. So how do you do that? So what you can do, in order to factorize this polynomial, you can think of this as we have something called an identity, which is a squared minus b squared is equal to a plus b times a minus b. Okay, so now if I somehow rewrite this polynomial in this form, then I can use this identity in order to factorize it. So I write this as p of x is equal to x squared, and 3 you can write it as square root of 3 whole squared. So square root of 3 whole squared is equal to 3 basically. So I have rewritten the polynomial in this way. Now this is a squared minus b squared. So therefore it's equal to a plus b, x plus square root of 3 times a minus b, which is x minus square root of 3. So now this is basically the factorized version of your polynomial. And in order to find the zeros, if you set your polynomial equal to 0, x plus square root of 3 times x minus square root of 3 is equal to 0. And so either this is equal to 0 or this is equal to 0. So this one gives me x1 is equal to negative square root of 3. And this one gives me x2 is equal to positive square root of 3. And take this, for example, alpha and beta, for example. Okay. Now, over here, your polynomial was p of x was equal to x squared plus 0x squared plus 0x minus 3. That means that your a is equal to 1, your b is equal to 0, and your c is equal to negative 3. Now if I calculate alpha plus beta, that's equal to basically negative square root of 3 plus square root of 3, which is equal to 0. Negative square root of 3 plus square root of 3 is equal to 0. And also b divided by a, if I calculate in this polynomial here, is 0 divided by, actually it's negative b by a. It's actually negative b by a, but doesn't make any difference really, but it's negative b by a. So negative b by a is equal to negative b, which is equal to 0, over a, which is equal to 1. That's equal to 0. So you can see that alpha plus beta is still equal to negative b by a. And another relationship that we can check here, if you basically calculate alpha beta, it's going to be equal to negative square root of 3 times square root of 3, which is equal to negative 3. And c by a here is equal to negative 3 divided by 1. C by a is equal to negative 3 divided by 1, which is actually negative 3. So you see that alpha beta is equal to c by a. So again, alpha plus beta is negative b by a, alpha beta is c by a. So let's do another example as well. Let's do another example as well, but before we do that, I'll take a few minutes rest. Okay, so as another example, okay, so let's say that the sum and product of the sum of the, basically the sum of the let's say that the sum of the zeros, so the sum of the zeros of a polynomial of course it's a quadratic polynomial, is equal to, the sum is equal to negative 3, and the product of the zeros of a polynomial quadratic is equal to 2. And you want to basically find out what that polynomial is actually. So you know that the sum of the zeros would be alpha plus beta, which is equal to negative b by a, which is equal to negative 3. And the product of the zeros, alpha beta, is equal to c by a, and that's equal to 2. Okay? So now what we know from this situation is negative b by a. Negative b by a is equal to negative 3, and c by a is equal to 2. So what you can do, let me see, think about this. Okay, so basically what we have here is that basically you have the sum of the the sum of the zeros of a polynomial is -3, and the product of the product is 2, right? So I don't really, and then let me see, the b by a, basically there is, I mean, at least right now I cannot find a way to actually find these, at least find these directly in order to solve this problem. So one way that I could find to solve this problem was that basically if you have a polynomial of degree 2 which is quadratic, you can find that polynomial as, for example, something like p of x, which is ax squared plus bx plus c. Okay, and then you can factorize this polynomial as basically, let's say that x1 and x2 are the two factors of, basically if alpha and beta are two zeros of this polynomial. Let's take that alpha and beta being the, of course I'm just doing some sort of experiment here. I don't know really where that takes us, but let's do this experiment. So if alpha and beta being the two zeros of basically p of x, then you know that basically the polynomial can be written as x minus alpha times x minus beta. That you can write, meaning that x minus alpha times x minus beta is going to give you the polynomial back, right? So what that means is that and that's actually x. So what that means is that if you actually multiply here, you will get x squared minus beta x minus alpha x and plus alpha beta, and that is equal to x squared minus alpha plus beta times x plus alpha beta. So what that means is that I mean, it actually makes sense that there is this relationship between these coefficients and the roots of the polynomial, meaning that basically this polynomial was ax squared minus plus bx plus c. So now I have written the same polynomial. I have written it in terms of the zeros, and then if you multiply it, you'll get basically you will get it in this form, basically these are the roots of this polynomial. So then you can say that your b over here is minus alpha plus beta. Your b is minus alpha plus beta. Your c is alpha times beta, and your a over here is actually equal to 1. Okay, so that's basically, and the relationship that I can find over here between so for example c by a would be alpha beta c by a would be alpha beta, and negative b by a. So this is b and this is a, so negative b by a would be alpha plus beta. So you see, these actually come from here. I was actually kind of confused, and I didn't know how they'd gotten this. But this is actually a very simple thing, meaning that any sort of second degree polynomial, you can write it as a product of its factors. And for example, if you have a polynomial ax squared plus bx plus c, this is a quadratic polynomial. The factors of this polynomial are basically, this is a polynomial in x, right? So, and the degree is 2. So you have basically, of course, two factors multiplied together to get you to the polynomial that you had. And of course, since it's a polynomial in x, you have x over here and x, and then you have basically the polynomial has basically some sort of roots. Let's call them, for example, alpha, and let's call this beta. And of course, you know that the factor has to be in the form x minus alpha, because when you equate that to 0, then when you solve that equation, that has to give you your actual root or your actual 0. So now in this equation, x is equal to alpha, x, and in this equation, if you equate that to 0, that will give you x is equal to beta. Okay, so that's basically so that's basically why you can write this equation as x minus alpha times x minus beta. And then once you have your polynomial factorized in this form in terms of the and by the way, as long as we are here, this is called one factor of this polynomial, and this is another factor of this polynomial. And then once you get into the factors, you can then get into the zeros, which is basically this alpha is the 0 and this is the 0, but x minus alpha becomes a factor of the polynomial, and then you have another factor of the polynomial. When you multiply the two factors, you will get the polynomial itself. That's basically how these polynomials actually work. Okay, so now that you have your polynomial written in the factorized mode, that means that you are multiplying two factors together in order to get to your polynomial. Now if you actually multiply these together, you'll get x times x is equal to x squared, and that is negative beta times x, and then negative alpha times x, and that is plus alpha beta. Okay, so you can write this as x squared, and you can take the x out, and negative x, you can take it out, and then you can write this as alpha plus beta, and then plus alpha beta. So then you can write this as x squared plus, minus alpha plus beta times x plus alpha beta. So now as you can see, if you compare this equation that you got here to the original equation that you had here, or to the original polynomial that you have here, for a you have a 1 over here, for b you have a negative alpha plus beta, and for c you have a alpha beta over here. So then of course it makes sense that, for example, c divided by a is equal to, well, alpha beta divided by 1, which is alpha beta, the product of the two zeros, or the product of the two roots of the polynomial. and then negative b by a is going to give you negative, basically negative of negative alpha plus beta divided by 1. Okay, and that is equal to negative b by a is equal to negative of negative alpha plus beta. Okay, and then that is equal to alpha plus beta. So that means that negative b by a is equal to alpha plus beta. So that's basically how they have gotten these relationships between alpha, beta, AC, and AB and C. Now, about that particular problem that we were solving there, we said that the sum of the two roots of that polynomial was negative 3, and the product was 2. Negative 3 and 2. Negative 3 is equal to alpha plus beta, and 2 was the product of the two roots of the polynomial. Now, the way that you can solve this problem, I'm just assuming that I have a quadratic polynomial in the form ax squared plus bx plus c, and how can I basically solve this problem? I can write this polynomial in the form. I can write this polynomial in the form x minus alpha being one of my roots, times x minus beta being basically the other root. Okay, so then what I can do, is that let me see. Okay, so now I know that alpha plus beta is equal to negative 3, alpha beta is equal to 2. So you can use these two equations simultaneously in order to solve for alpha and beta. So if you call this, for example, number 2, and if you call this number 1, so based on 2, you know that alpha is equal to 2 divided by beta, for example. 2 divided by beta. So if you substitute this equation in 1, what you will get is that alpha is basically 2 by beta. So negative 3 is equal to 2 by beta plus beta. And that means that negative 3 is equal to beta and 2 plus beta squared. And that basically means that negative 3 beta is equal to 2 plus beta squared. And what that means is that beta squared plus 3 beta plus 2 is equal to 0. Now, if you solve this equation, you'll be able to have two values for beta. Okay, so let's solve this equation first, and then we'll go back there and find out what alpha is. So here you can factorize this equation. You can write it as beta squared plus 2 beta plus beta plus 2 is equal to 0. So then you can take these two terms together and write beta times beta plus 1 plus 2 times these two terms together, 2 times beta plus 1 is equal to 0. And that gives you beta plus 1 times beta plus 2 is equal to 0. So that means that beta is equal to negative 1, or beta is equal to negative 2. Okay, so now I have two values for beta here. Now if I go up here, we said that alpha beta is equal to 2. 2 gives me alpha beta is equal to 2. So so now if beta is equal to -1 from here, then what that means that alpha beta, so alpha times -1 is equal to 2. That means that alpha is equal to 2 divided by -1, which is equal to -2. That's some value for alpha. And then if beta is equal to -2, then alpha times -2 is equal to 2 from here. So alpha is equal to 2 divided by -2, which is equal to -1. Right? So this gives me basically two answers over here. Either alpha is equal to -2 and beta is equal to -1. This is basically one answer. Or basically the second case would be alpha is equal to -1 and beta is equal to -2. That's basically the other case over there. Now up here we said that basically our polynomial was x minus alpha times x minus beta. So x minus alpha times x minus beta times x minus beta. Okay, so what that means is that I can use basically these two cases to come up with two polynomials. So I call this case number 1. I call this case number 2, although I have used these before, but this one and 2 are not the same thing. Okay, so now I write alpha minus 2 beta -1. So I can write this as I can write this as x minus alpha, which is x plus 2, times x minus beta, which is x plus 1. This is one polynomial that I can get. Over here I have the same thing, x minus alpha times x minus beta. So basically x plus 1 times x plus 2. So this, and you can see that both of these cases are actually the same thing. This is x plus 1 times x plus 2. This is x plus 1 times x plus 2. So I can just forget about this case and carry on with this case, for example. And I call this, for example, p of x. Now if you multiply these together, you'll get x squared plus x plus 2x plus 2, and that's equal to x squared plus 3x plus 2. That's equal to p of x. Now you see that your polynomial is actually x squared plus 3x plus 2, and if you want to test it, you can actually solve this polynomial to find the zeros. So you can basically write this as x squared plus 2x plus x plus 2, and then you can write it as x times, take these two together, x times x plus 1 plus 2 times, take these two together, 2 times x plus 1, and that's equal to x plus 2 times x plus 1. Okay, so that means that this is your p of x. That means that your roots are going to be basically, if you want to find the zeros, what you would do is that you would set this equal to 0. So x plus 2 times x plus 1 is equal to 0. Either one of them is going to be equal to 0, either this one or that one. So that's x plus 2 is equal to 0, or basically x plus 1 is equal to 0. So here it gives me x is equal to -2 or x is equal to -1. Now what that means is that I call this, for example, alpha and beta for the sake of simplicity, the two zeros. And now alpha beta, the product of these two is equal to 2, and alpha plus beta is equal to -3. And that's basically what we had over here somewhere, I don't know. Somewhere over here, alpha plus beta was -3, alpha beta was 2. That's basically the same thing, okay? Now, of course, any sort of of course, the polynomial that we were looking for basically is p of x is equal to x squared plus 3x plus 2. But then you can generally say that generally any sort of polynomial that can be written as k times x squared plus 3x plus 2, where k is a real number, is will fulfill those conditions that we talked about in the beginning of the problem, meaning that you can always take your k out, and then your polynomial will be in this general form. Okay, so in the next video we are going to talk about cubic polynomials and the relationship between the coefficients and the roots of the polynomial. So I'll see you in the next video.